The Malpasset Dam Collapse. December 2nd, 1959, southern France, 9:14 p.m. A 60-meter concrete arch dam shatters in 10 seconds. 50 million cubic meters of water explodes down the Rayran Valley at 70 kilometers per hour. The wave is 40 meters high, taller than a 13-story building. Villages vanish in 60 seconds. Not damaged, erased. 423 people killed, 135 of them children. Many drowned in their beds, never knowing what hit them. The brutal twist? The dam's concrete was flawless. Engineers built a perfect structure on fractured gneiss rock riddled with faults. Foundation investigation, inadequate. Geological surveys, superficial. Water pressure built beneath the base like a hydraulic jack until physics won. The dam worked beautifully, the geology didn't. After Malpasset, the rules changed forever. Deep foundation drilling became mandatory worldwide. Hundreds of test boreholes before 1 kilogram of concrete. The lesson? Perfect engineering on bad ground equals mass disaster. The Vajont Mega Tsunami. October 9, 1963. Northern Italy, 10:41 p.m. 260 million cubic meters of mountain, Mount Toc, slides into a reservoir in 45 seconds. That's 350 times the volume of the Great Pyramid. Impact speed? Over 100 kilometers per hour. The water doesn't splash, it detonates. A megatsunami shoots 250 meters straight up, higher than a 70-story building. The wave splits in two. One destroys villages upstream. The other, carrying 30 million cubic meters, surges over the 261-meter dam. Downstream, the wall of water is 140 meters high. Longarone, population 1,910, sits directly in its path. 10:43 p.m., the town exists. 10:47 p.m., it's gone. 4 minutes. Only 500 bodies recovered, the rest simply vanished. Total death toll, nearly 2,000 people. The dam? Still standing today, completely intact, not even cracked. Engineers knew the mountain was moving, 3.5 centimeters per day for 3 years. They thought they could control it by lowering water levels. They tried to stop 260 million tons with a drainage valve. The investigation revealed fraud, ignored warnings, suppressed geological data. Vajont redefined engineering responsibility forever. You're not building a structure, you're redesigning an entire geological system. Ignore the environment, and physics sends the invoice written in lives. The Aberfan Spoil Tip Collapse. October 21st, 1966, Wales, 9:15 a.m. Tip number 7. A 111-meter mountain of coal mining waste sits above Pantglass Junior School, built directly over underground springs, swollen with 2 weeks of rain. 140,000 cubic meters of coal slurry liquefies and begins sliding. Speed, 40 kilometers per hour down the hillside. At 9:17 a.m., 2 minutes after movement starts, it hits the school. A 5-story wave of black sludge smashes through the rear wall. Classrooms fill instantly. Children buried under 12 meters of waste. Miners, many of them fathers, dig with bare hands. 28 children pulled out alive in the first hours. After that, hope dies with every hour that passes. Final count? 144 dead, 116 of them children aged 7 to 10. This wasn't an accident, it was documented negligence. In 1963, 3 years before, engineers warned Tip 7 was unstable and waterlogged. Recommendation: stop using it immediately. Action taken? None. Coal production continued, the tip grew higher. Warnings ignored. Aberfan forced Britain to overhaul mining waste regulations completely. It established a legal principle. Ignoring known hazards isn't negligence, it's culpability. The 116 children are buried together in 2 long rows. They were learning arithmetic that morning. They never went home. Turkish Airlines Flight 981, March 3, 1974, 12:40 p.m. Flight 981 climbs through 11,500 feet after leaving Paris. 346 people aboard. Destination, London. Then the rear cargo door, improperly latched due to design flaw, blows out. Explosive decompression at 500 miles per hour. The cabin floor collapses downward, severing 6 critical flight control cables beneath it. Pilots lose control of elevators, rudder, engines, everything, in 2 seconds. The aircraft pitches into a 20-degree nose-down dive. Speed, 800 kilometers per hour. Trajectory, uncontrollable spiral. At 12:41:50, just 77 seconds after door failure, it slams into Ermenonville Forest. Impact so violent the largest intact debris piece is 4 meters long. 0 survivors. 346 people dead. Here's the nightmare. This exact failure happened before. 2 years earlier, American Airlines Flight 96 had the same door blow out. They landed safely. Investigators found the design flaw, recommended mandatory fixes for all DC-10s. McDonnell Douglas issued a suggestion, not a requirement. Airlines could ignore it. Turkish Airlines did. Modification cost, $10,000 per aircraft. Cost per life saved, $28. Flight 981 revolutionized aircraft certification. Redundant control systems became mandatory. Single-point failures eliminated. Legal precedent established. Manufacturers are criminally liable when known flaws aren't fixed. 346 people died because a $10,000 fix wasn't mandatory. The Alexander L. Keeland platform capsized, March 27, 1980, North Sea, 6:27 p.m. 212 oil workers on a 5-legged semi-submersible platform, 320 kilometers offshore. Wave height, 12 meters. Wind, 70 kilometers per hour. Temperature, near freezing. A diagonal support brace, 6 meters long, several tons, suddenly fractures and breaks off. Origin, a 6 millimeter weld crack, invisible, growing through metal fatigue for months. Platform tilts 30 degrees in 15 seconds. Anchor cables snap. Tilt accelerates, 35 degrees, 40 degrees, 45 degrees. At 6:30 p.m., 3 minutes after initial failure, the platform capsizes completely. Workers trapped inside, now underwater in pitch darkness. Of 8 lifeboats, only 1 deploys successfully. Others jam or crush. Survivors jump from 40 meters into 2 degrees Celsius water. Hypothermia window, 15 minutes. 123 people killed. 89 survived. The crack started at a small welded sonar mount on the brace. Poor weld quality. Stress concentration. Every wave cycle caused microscopic growth. 5 years of invisible damage until structural capacity reached 0. The inspection regime, considered adequate, couldn't detect it. The crack was inside a sealed structural member. By the time it showed externally, it was critical. Keeland transformed offshore engineering. Fatigue analysis, mandatory. Weld quality standards, completely overhauled. Damage tolerance, design requirement, not afterthought. In harsh environments, invisible damage is always growing. If you can't inspect it, you can't trust it. The Val di Stava tailings dam collapse. July 19, 1985, northern Italy, morning. 2 earth dams above Stava village store mining waste, mud, sand, water. Raised higher and higher for years without proper reinforcement. Drainage, inadequate. Monitoring, minimal. Warnings, ignored. The upper dam fails. Released slurry hits the lower dam seconds later. Both collapse simultaneously, unleashing a fast-moving wall of mud and debris. Speed, racing down the narrow valley like an avalanche. Everything in its path, homes, hotels, bridges, obliterated. 268 people killed. An entire community ceases to exist in minutes. This wasn't a freak accident. It was chronic regulatory failure, poor design geometry, 0 independent oversight, years of warning signs dismissed. Val di Stava became one of the world's most studied tailings disasters. It proved these structures aren't passive. They're living systems demanding constant control. Raise them without engineering discipline, and they become weapons. The Chernobyl reactor explosion. April 26, 1986. 1:23 a.m. Chernobyl nuclear power plant, Ukraine. Operators attempt a safety test under unstable reactor conditions. Design flaws combine with procedural violations. Power surge goes critical. The reactor explodes. The core destroyed. Graphite fire burns for days. Massive radioactive release spreads across Ukraine, Belarus, much of Europe. Contamination cloud crosses national borders, reaching as far as Scandinavia. Firefighters rush in without understanding the lethal radiation. Many absorb fatal doses within hours. Nearby residents not warned immediately. Evacuation comes too late for thousands. Short-term deaths, dozens. Long-term health effects, thousands. Thyroid cancers spike among exposed children across multiple countries. Chernobyl wasn't a single failure, it was systemic collapse, design vulnerability, operational pressure, weak safety culture, secrecy, all converging at once. The disaster transformed nuclear engineering worldwide. Reactor designs fundamentally altered, safety culture revolutionized, international nuclear standards completely rewritten. It proved complex systems fail catastrophically when transparency is suppressed, and radiation doesn't respect borders, politics, or lies. The Piper Alpha Platform Disaster, July 6, 1988, North Sea, 10 p.m. Piper Alpha, an oil production platform, is undergoing routine maintenance, a safety valve removed from a condensate pump, work unfinished by shift change, communication breakdown, the night crew doesn't know. They restart the pump, pressurized gas escapes. First explosion ignites fires so intense they melt structural steel. Pipelines rupture, feeding more fuel directly into the inferno. Emergency systems fail. Escape routes cut off. Workers face a choice, burn alive or jump 50 meters into the sea. Many jump from heights that make survival impossible. By morning, 167 dead. Investigation reveals systematic safety management collapse. Poor communication, flawed permit-to-work systems, platform design that allowed fire to overwhelm critical systems within minutes. Piper Alpha permanently transformed offshore safety regulation. Hazard management became priority one. Production speed became secondary. It proved that paperwork errors can become physics when explosive energy is involved. A missing permit note, a conversation not had. 167 people dead. The sinking of the MS Estonia, September 28, 1994, 1 a.m., Baltic Sea. MS Estonia, a roll-on, roll-off ferry, crosses rough seas en route to Stockholm. Loud impacts heard from the bow. The bow visor fails under wave loads. It wasn't designed to withstand forces it was experiencing. Water floods the vehicle deck rapidly through the open bow door. The ship develops a severe list and capsizes within an hour. Passengers trapped below deck in darkness, freezing water, violent weather. 852 people die. It's one of Europe's worst maritime disasters. The failure revealed fundamental design vulnerability in ro-ro ferries. Once water enters the vehicle deck, free surface effect destroys stability instantly. Capsizing becomes inevitable. Structural weaknesses compounded the problem. Estonia forced sweeping changes in passenger ship safety across Europe. New stability requirements, bow door locking systems redesigned, evacuation procedures completely overhauled. It remains a brutal reminder. Ship design that looks safe on paper can kill hundreds when physics takes over. The Archiv high-speed train disaster, June 3, 1998, northern Germany. Speed, 200 kilometers per hour. Ice high-speed train racing through the countryside. A wheel fractures due to metal fatigue. The crack hidden inside the structure for months. At full speed, the wheel disintegrates. Train derails and slams into a concrete overpass at 200 kilometers per hour. The bridge collapses onto the passenger cars below, crushing them instantly. 101 people killed, dozens severely injured. This wasn't a collision. It was fatigue failure, a small defect growing silently until physics took over. No warning, no time to react. Archiv exposed critical limitations in early high-speed rail systems. Inspection methods couldn't detect hidden damage. Engineers underestimated how quickly defects progress at extreme speeds. The disaster transformed rail engineering across Europe. Wheels completely redesigned. New monitoring systems deployed. Inspection regimes made far more rigorous. At 200 kilometers per hour, small errors leave zero margin. Fatigue doesn't announce itself. It just kills. The Mont Blanc Tunnel Fire, March 24, 1999. Deep beneath the Alps, a truck catches fire inside the Mont Blanc road tunnel. Vehicle fire escalates into a tunnel-wide inferno within minutes. Smoke fills the confined space. Temperatures exceed 1,000 degrees Celsius. Drivers trapped behind the burning truck have nowhere to escape. Ventilation systems struggle. Communication fails. Rescue teams blocked for hours. 39 people die, most from smoke inhalation, not flames. The tunnel itself became the death trap. Limited fire compartmentation, inadequate emergency refuges, ventilation not designed for modern fire loads. Mont Blanc forced complete rethink of tunnel safety across Europe. New standards for fire detection, ventilation control, emergency response. Emergency exits spaced closer. Fireproof refuges mandatory. Underground infrastructure offers no forgiveness. In a tunnel, smoke doesn't just kill, it hunts. The Kaprun Funicular Tunnel Fire, November 11, 2000, Kitzsteinhorn Mountain, Austria. A funicular railway catches fire shortly after leaving the station. Train stops inside a steep tunnel. Smoke rises rapidly uphill. The tunnel acts like a chimney, pulling smoke upward at deadly speed. Passengers flee upward, directly into the smoke. Visibility drops to zero within minutes. Oxygen vanishes. 155 people die, most within 500 meters of where they started. The failure was design, not just fire. Materials unsuitable for tunnel conditions. Emergency exits inadequate. Evacuation planning fundamentally flawed. Survivors who went downhill, against instinct, into darkness, lived. Those who went uphill, following the light, died. Kaprun reshaped safety standards for cable railways worldwide. It stands as brutal proof. In confined spaces, smoke, not fire, decides who survives. Human instinct says go up toward light and air. In a tunnel fire, instinct kills you. The Grenfell Tower Fire, June 14, 2017, London, 1 a.m. Small kitchen fire breaks out in a high-rise apartment tower. Under normal circumstances, it should remain contained to one unit. Instead, flames reach the exterior cladding. Combustible panels and insulation allow fire to race vertically. The building's facade becomes a highway for flames, entire tower engulfed within minutes. Smoke and heat trap residents inside their homes. Many followed official advice, stay put and wait for rescue. For those on upper floors, that advice became a death sentence. 72 people killed. This wasn't firefighting failure, it was design, regulation, and oversight failure. Cost-cutting decisions replaced fire-resistant cladding with combustible materials, materials testing inadequate, regulatory enforcement weak, safety warnings from previous fires ignored. A single apartment fire became a whole building catastrophe because saving money mattered more than saving lives. Grenfell shattered public trust and triggered sweeping reforms. Building safety regulations completely rewritten across Europe. Material standards overhauled. Accountability frameworks strengthened. It remains a modern warning. Value engineering is sometimes just code for acceptable casualties. The Morandi Bridge Collapse, August 14, 2018, Genoa, Italy. Storm conditions. The Morandi Bridge, a major highway structure, suddenly collapses. A central span gives way without warning, dropping vehicles into the void. 43 people killed in seconds. The bridge had been deteriorating for decades. Corrosion eating through support cables, concrete degrading. Design made inspection difficult. Maintenance deferred repeatedly. Concerns raised for years. Action taken, minimal. The failure wasn't sudden. It was cumulative. Decades of neglect, material degradation, unresolved design challenges, all converging into a single moment when structural capacity reached zero. Morandi triggered nationwide infrastructure scrutiny, governments forced to confront the cost of deferred maintenance, the hidden debt of aging structures across Europe. It stands as a symbol. Infrastructure doesn't fail overnight, it sends warnings for years. The collapse is just the announcement. The Hyatt Regency Walkway Collapse, July 17, 1981, Kansas City, Missouri, 7:05 p.m. 1,600 guests packed the Hyatt Regency Hotel atrium for a Friday night tea dance. 3 suspended walkways span the lobby, 120 feet long, 64,000 pounds each. The 4th floor walkway's box beam connection fails. It drops onto the 2nd floor walkway beneath it. Both collapse simultaneously onto the crowded dance floor. Impact time, 2 seconds, 114 dead, 216 injured, the deadliest structural collapse in U.S. history at the time. The cause, a catastrophic design change. The steel fabricator switched from continuous ceiling rods to a 2-rod system. The 4th floor walkway now carried double the load. The engineering firm approved the change without calculations. National Bureau of Standards confirmed. Even the original design only met 60% of building code requirements. The walkways would have failed under 1/3 of the weight they held. Engineers lost licenses. Firms bankrupted. Standards revolutionized. One unapproved design change. No analysis. 114 dead in 2 seconds. Across dams, tunnels, reactors, trains, towers, and bridges, the pattern never changes. These failures weren't inevitable. They were engineered through human decisions. Warnings ignored. Margins eliminated, systems pushed beyond limits. When failure came, it was fast, violent, and unforgiving. Engineering doesn't fail quietly. It fails in seconds and kills in numbers. The most catastrophic disasters in Europe teach one lesson. Safety isn't an add-on. It isn't a checkbox. It isn't a suggestion. Safety is the system. When that system breaks, history records the cost in lives, graves, and memorials. The question isn't whether the next disaster will happen. The question is whether we've learned enough to prevent it.